So let's get started with Unit 1 of Applied Statistics 2. So Unit 1 is Analysis of Variance and Design of Experiments. So in this, the most important thing is what we are going to cover in this chapter. Okay. So the syllabus, I will just give you an overview of it. We are going to cover analysis of variance and design of experiments, concept of Gauss Markov linear model with examples, statement of Cochran's theorem, ANOVA, that is one-way, two-way classifications with one observation per cell, experiment of various sums of squares, statistical one analysis, importance and application of design of experiments. Okay, so first let us understand what do you mean by ANOVA. So ANOVA is the acronym of analysis of variance. Analysis of variance, okay. So analysis of variance is a statistical technique specially designed to test whether the means of more than two quantitative populations are equal. That is, to make inferences about those whose samples are drawn from the populations having the same mean. And where is it used? It is used in education, industry, business, psychology fields, mainly in their experimental design. So it helps to save time and money as several population means can be compared simultaneously. So it is used to test the linearity of the fitted regression line and correlation ratio, significance test statistic of ANOVA. Okay. Then after ANOVA, you have DOE. DOE is design of experiment. So what is design of experiment? It is one of the techniques used for determining and controlling the parameters or variables which have significant effect on the resistance output of the process. So the purpose of using DOE is to make efficient design of the process. Okay, did you understand this? So now let us get started with Gauss-Markov theorem. Very, very important. Gauss-Markov theorem. Now suppose the expectations of a set of n independent random variables yi are given as linear functions of p unknown parameters beta 1, beta 2, so on up to beta n with known coefficient aij's and constant variances sigma square. Therefore, E of yi is equal to ai1 beta 1 plus ai2 beta 2 plus so on up to aip beta p for all I takes values from 1 to n. Now V of yi is equal to sigma square. COV of yi dash is equal to 0, such that I is not equal to I dash. Now let us say y is equal to y1 so on up to yn dash. Beta is equal to beta 1 so on up to beta n dash. Alpha j is equal to a1j a2j so on up to anj dash, where j takes values 1, 2, so on up to p. So A is equal to alpha 1, alpha 2, so on up to alpha p. Now equation number 1 can be written as E of y is equal to n, that is equal to alpha 1 beta 1 plus so on up to ap beta p. Let's say this is equation number 2. What did we take equation number 1? See, this is equation number 1, E of yi. After we got equation number 2, that is equal to a beta. Then dispersion matrix of y will be d of y is equal to sigma square I, where I is identity matrix of order n. Similarly, equation number 1 can be written as y is equal to a beta plus e. So E of E is equal to 0. So D of E is equal to sigma square I. Let's say this is equation number 3, where E is equal to E1, E2, so on up to En whole dash, which is a column vector of n independently distributed errors. That is E1, E2, E3, so on up to En. Hence, equations 1, 2, and 3 are known as Gauss-Markov linear model. Now we will see Cochran theorem. Cochran's theorem. So let us see what is the statement of Cochran's theorem. Let x1, x2, x3, so on up to xn be distributed random variables from normal population. Normal population is denoted by n of 0, comma sigma square. Assume that sum of squares of these values is sigma I is equal to 1 to n, xi square is equal to q1 plus q2 plus q3 plus so on up to qk. Where q1, q2, q3, so on up to qk are quadratic forms in the random variables. Random variables are x1, x2, so on up to xn with rank Ri, where I is equal to 1, 2, so on up to k. Then qj, where j takes values 1, 2, so on up to k, are mutually independent. Which means change in one will not affect the other. And qj by sigma square is a xi square variate with rj degrees of freedom. If and only if, the condition I am writing it over here, if and only if sigma j is equal to 1 to k, rj is equal to n. So this was the statement. Now let us see what are the applications of this theorem. So write down some of the applications in Cochran's theorem are number 1, it is used in handling the sum of squares from a linear model. Number 2, it is used in the decompositions of ANOVA that is used in balanced two-way layouts. Now we will take up ANOVA. What is ANOVA? So as I told you, analysis of variance is ANOVA. It is the collection of powerful statistical models and their associated techniques which help us to examine variance. So as we know, variance is denoted by sigma square between a number of samples. So technically, ANOVA is an experimental design which helps us to compute the variations between means of the groups by dividing the total difference in the given data into two components, that is within group variance, that is sigma square, or residual variance, and in between group variance. Now let us write a few more points about it. The term ANOVA was first coined and its complete systematic procedure was developed by R.A. Fisher. Hence, ANOVA is also known as Fisher's ANOVA. And the systematic procedure contains classification and cross classification of the statistical results obtained and examination of the means of classification for specific variations.